So this is two 40-foot shipping containers in line with each other. This is an example of basically a 20-foot intermodal shipping container where we've cut out the full 8-foot cross section and we have an opening in the side of a 40-footer. And this is an example of just taking a 40-foot container, putting a door in it, and it's the same 20-foot container as that's on the other side, just a different configuration. So where this has a door in it, that one has a larger space. It opens up this part of the facility to be more useful. When we're done, this will be the kitchen and dining area, and then there's a small bathroom and washroom. So this is the manufacturing area. This is actually where we'll bag and store and palletize the material. This is a 30 by 50 square foot area, but it's 65 feet high, so we have 3 stories of manufacturing space. So inside the structure, we have 2 large storage bays. One's a mirror image of the other. But basically this area will be filled with biomass, and we manipulate this material with a large overhead crane with a clamshell so that we can manipulate this material throughout the building. Each one of the silos has a 12-inch auger inside of a 16-inch tube with a vibratory floor, and we can feed the material inside the building or outside the building. There'll be a trough that is underneath here, and that's how we manipulate the material from the silos throughout the facility as well. This is just the tunnel. It just gives you maintenance access to all of the augers. We have 2 14 by 11 hydraulic doors. This is the other large bulk storage area in the facility. When we're operational, both these doors will all be closed, and this is just so that in case we have an emergency, we can open up and get access to the large storage area. This will be approximately 60 feet long, 30 feet high, and 21 feet wide area that we can fill with biomass. The facility sits on 1 acre, and the building itself is 70 by 102, and then the rest of the acreage will be processing or grinding material on this side for contaminated materials, contaminated meaning metals, plastics, cardboard, those types of products. And on the other side, we'll process our corn stover, wheat straw, bean stubble, those types of materials where there's less contamination. So we'll process them, and we'll have 2 conveyors that'll take that material to the top of the facility. That's what that conveyor there is. In the back of the lot, basically we have our electrical input comes in back there. We call that Powerhouse 1. All of our electric comes in there. And then in here is Powerhouse 2. So our utilities come inside the facility here. There's a utility corridor that goes down the center of the building. And then all of our PLC controls are in this cabinet to control all the motors, conveyors, and so on and so forth above. And then above us in a 20-foot shipping container is a 300-gallon compressor. We use a lot of pneumatics inside the building. We have 2 compressor rooms. You have to remember each one of these was a shipping container, but once it left my place, it was a module. And there's a total of 60 modules. So this is the 2nd floor manufacturing, 3rd floor in the containers, but 2nd floor manufacturing. This is where the briquetters, the pelletizer, the shape making equipment will be on this floor. The auxiliary equipment to power that is all in that container behind it. And then we use gravity as our friend. Everything comes in at the top of the facility, is sized and stored, fed into conditioners, and then fed into the briquetters. And then the material is sent to either the appropriate silo and or bagged to be shipped out. What was more important to me is what my market within a 30-mile radius wants. So if they want a log that's 5 inches in diameter, 12 inches long or 16 inches long, that's what we want to produce. And the briquetting and densification industry as a whole throughout the world has been around for a long time. So we don't have to reinvent that technology, but we need to pay attention to what our markets want within a particular area. So if you have a market with a lot of outdoor wood boiler people that want a particular log size, then you need to make the product that they want. If you have a coal burning power plant close by, then you're going to want to make a briquette that flows and works with their particular type of technology within their facility. You don't want to have to deliver a product to a potential customer that they have to make work. So that's what designing these facilities flexible is about being able to change and modify the inside of the facility based on what the market is within that particular region, whether it's cellulosic ethanol, feed for cows or chickens or deer or whatever it is. Once you know what that market is and what they want, then you can modify the facility to adapt to meet that market needs. The problem is having the appropriate equipment sized for the facility within a particular region. In the United States, we build typically large, giant facilities that require thousands of tons every day to be delivered to them. And trying to find low-value material within a close proximity to those facilities becomes a problem. We believe it's more economical to design a facility around a 100 tons per day need and then build more facilities throughout that area to where you can take the low-value materials, travel a short distance, and then your higher value products that you manufacture, you can deliver 400, 600, 1,000 miles away and have a better value and a smaller carbon footprint. In the state of Illinois, we produce a large amount of coal-generated power. So obviously I'm targeting being able to put a large number of these facilities because it takes 10 of this size facility to supply a 1 to 2% blend at any coal-generated facility in the state of Illinois. So you can see that the dynamics of scale are achievable to supply a particular end market. There have been multiple sites throughout the United States over the last 30 years that have been doing testing on how to blend biomass and work with coal. Our plan is to create a predictable emissions product that will integrate into our existing coal generating, giving them the ability to generate less emissions utilizing a percentage of biomass with their coal every day. We believe that biomass is coal's best friend, they just don't know it yet. This is the third floor container room. This will be the clean room that's just off of the manufacturing and briquetting area. And this will be filled with the equipment to test the biomass products for solubility, density, and chemical makeup for our customers. This will be the loadout conveyor. It is on the third floor. Basically, it can load out trucks in the front of the facility. We'll be loading 100 cubic yard trucks in about 15 minutes. The clamshell will drop them into the hopper, and the material will be staged, and the moving floor conveyor will move that material out to the end and load the truck. This is our where we manufacture our erosion control logs. That's a 3 cubic yard hopper, an 8-inch or 6-inch auger. We typically make an 8-inch stock, 10 feet long. This is on the fourth floor, which is the highest floor of the middle section of the building. And it's so the overhead crane can basically fill the hopper to manufacture the material. We typically make about 2,000-3,000 socks a year. We made up a bunch. We had an inventory up here. We obviously sold all them, and now we're getting ready to make our next batch for spring.
You must have a consistent customer, or is it just varied? You get a call, somebody says, I'm looking for socks?
It typically is run by building permits. Depending on how many building permits you get within a particular region, that dictates how many houses that are required. You have to have an erosion control permit if you're going to build a house or a Kentucky Fried Chicken, whatever it is. The erosion control socks take the place of a silk fence. The nice part about the erosion control socks is a homeowner can actually come pick them up and put them around their own job site. It's the big difference. They're also called wattles. If you've looked in a ditch where you've seen them staked in the ditch for erosion control, they call those wattles. Ours are made with 100% recycled material. Some of them they make out of grasses. The deer like the grass ones because they can eat them. With ours, once you're done with them, you cut them open and they're mulch. You can put around your trees. This is the her restroom, and this is the him restroom. So this is our control room. Basically, this will be filled with all the on-off operational lights. Everything throughout the facility will be video monitored, so the walls will be full of monitors. Because of the cavernous type structure, a person can't see all of the conveyors and functions in a row. They can see that from here, so they can make sure that all of the conveyors that need to be on in a row are operational and running properly. And if there's one that has a problem, they can shut the rest off. Anyone throughout the facility has to call this room to turn equipment on. They can shut it off anywhere in the facility, but they can only turn it on from here. So this is our central control tower. This is where we'll control most of run the PLCs in the first, third, and fifth floor in the back of the building as well. This is the operations office. This is where the scale master and the loadout master's office will be. This is a 20-foot intermodal shipping container. It's stacked on another 20, and there's 2 more 20-footers above us. What's unique about it is it has a stair module. Each 20-footer is a stair module. When you take those modules and stack them on top of each other, you end up with a stair tower. And that's how we are able to get to the 6th floor. From at the top of the steps here, if you look across, you can see a natural gas 15 kW genset. And that's backup 110 power for the facility. If the electricity goes out, then all of the LED lights are turned back on. This is our 4th floor maintenance area. Because we're going to have a lot of conveyors, bearings, maintenance equipment, so on and so forth, that's all on this level. You're close to where a lot of the mechanics are up above, so you don't have to go all the way down the 1st floor. This is the wall of the 2-story hopper. And then below us is the 60-foot long drag chain conveyor. This is one of the rooms with a view. But this is the view from my man cave. So now we're going up to the 4.5 floor. This floor is set up for the crane operator. He basically can see everything inside the facility and manipulate the material in the 2 large storage areas, put it in the hoppers, and anywhere it needs to go inside the facility, he'll have access with the overhead crane. We have 4 fans in the front of the building, 2 large fans in the back of the building, and we can evacuate the air in the building in a very short period of time. This is the 5th floor. These are the hallways to access all of the silos and maintenance for the rest of the facility. The 5th floor is all made up of 53-foot shipping containers, which are 8.5 feet wide and 9.5 feet tall and 53 feet long. The great thing about a 53-footer is you can clear span 50 feet with a 3-footer and still have enough to set on a ledge on each side. Allows us to have the flexibility in the facility. So this is 2 53-footers. These 53-footers sit on top of all of the 40-footers turned on end. Each place you see a grating is an access space for getting into each one of the silos. So this is the back of the building, 5th floor, and we have 2 53-footers that sit next to each other, and there's a 3rd floor manufacturing space. This is where the blending housers, the large capacity dust collection system, and where the materials will be blended and then dropped down to the next level. This is where a large blending hopper will set. There'll be 2 of them, one on this side, one on the other side. It's a mirror image. And then the cabinet in the middle is the PLCs that will control the blending hoppers and conveyors in the facility. Again, this unit is working with the other unit. This one is clear span. It's open underneath it. There'll be 4 hoppers that hang from the bottom side of this one, which will be the storage hoppers that store the material until the conditioners are ready for the material to the briquetters. Different view. This ladder will give us access down to the next floor below and all of the hoppers that are storing them. We have a single-person man lift that will be mounted on the second floor manufacturing area, and it will electrically raise the person up like an elevator into this area. So you will be able to take an elevator up to the 5th floor. This ladder is for emergency egress. Throughout the facility, we have to have a way. If there's a fire at the other end of the facility, you always have to be able to get out, and that's what this ladder is for. It just allows the people to have an escape if they can't go that direction. This is the hallway that covers the west side top of all the silos. This is the 25 horse capacity dust collection system. Really, all the dust is collected from the hammer mills and throughout the facility, and it's dropped into this particular silo right here. So all the dust will be collected, and then it'll be blended back into the product on an as-needed basis, depending on what product the customer is getting. Now we're going to go up to the 6th floor. This is the top level of the facility. Each end of the building is covered with a clear carbon fiber material, similar to what they use in greenhouses. And the roof is covered with a fabric material that allows natural sunlight to pass through. Today we've got a little snow on there, so there's a little less light, but we're in the middle of the day. Sun's not shining, but we have a lot of natural light in the building. Right now there are no lights in the building on. We have plenty of light to see throughout the building. One of the major feats that we had to tackle at this part of the building is the fact that this is what's called a half arch roof. A full arch would be 13 feet higher, and because it's not higher, it's a more difficult time holding up the load. But we built a truss out of two 53-foot shipping containers that allows us to have a 80-foot clear span for the crane to travel underneath, and also holds up the trusses and the snow load for us to work inside the building. So this is inside the two 53-footers. This is 106 feet long. There'll be two conveyors inside here. They'll basically bring the materials down to the large loadout hopper, the sock making hopper, and then the two large bulk storage areas can be loaded from the two conveyors that will be put in here. So this is the back of the building where the material comes inside the facility. We have a 75-foot belt conveyor right now installed here. There'll be another one installed on the other side. Those will bring the material from the ground level up to the top of the facility. From here, the material can move throughout the facility. It can go directly to a hammer mill on the right-hand or left-hand side, which is then sized appropriately and then fed down into the blending hoppers. Or it can proceed forward with the conveyors to the bulk loading area.